In traditional cloud computing, there is a central server at a remote location. For a simple scenario, let's take the example of 4 users. Each user sends data to be stored on the cloud so that they can access it later without storing it locally. Now each of the 4 users can send and retrieve data from the cloud. However, such a system might experience increased latency under heavy traffic or demand. A server like this also consumes a lot of energy, making it unsustainable, especially if the energy resource is a major pollutant. Thus, the current cloud computing setup is powerful, but does face some key challenges, especially because it can overtax the national grid. But before we move to holographic detail, we need to review some essential ideas under diffraction gratings. For all physics to follow, 2 conditions must be true. The light must be monochromatic, meaning of a single frequency, and it must be coherent, meaning that it should have a constant phase difference. A group of parallel monochromatic waves incident on a double-slit setup is diffracted. The waves spread out after passing through the slits. Now we can expand this to a 3D view for diffraction gratings. Consider a 4-slit barrier. The light is diffracted to produce this magnificent pattern. You can see 3 distinct diffraction orders on either side from the center. The equation that governs this is d times sine of theta equal to n times lambda. D corresponds to the slit separation. The angle theta is the angle between each order of diffraction and the center. N is the order of diffraction, and lambda is the wavelength of the wave. The result of this setup on an imaginary screen is this pattern of successive bright and dark fringes. But what causes this pattern? In comes the principle of wave superposition. Superposition is the vector sum of 2 waves. 2 waves that are pi radians out of phase destructively interfere with each other, giving a flat resultant wave. However, 2 waves in phase with each other combine constructively to give a resultant wave of double the amplitude of the initial waves. This interference of waves results in maximums and minimums on our imaginary screen. In the next video, we learn more about how holography and SLMs work. Hit that like button and subscribe for more quality content.